we have a MacBook Air and it's a no backlight. This has actually been assessed. I hope you guys can see that. That's a username. Can you see that? It's a username. What? Yeah. But we do not have. So this is not like the case of reduced backlight. No. So we don't have backlight at all. I was told that there was a repair attempt on the device. So they someone else tried to fix it. Yeah, but they failed, which is why it's here. So let's see what is it that they did, and also let us confirm what state the device is in, and then we can take it up from there. And they also mentioned that they replaced the screen, and it's definitely not the screen. That is from what they said. It's not a screen issue. The screen has been replaced, and then they tried to do a board repair, but was not successful. So let's see what is it. Okay, back cover is out. Okay, so I see that somebody breached. Okay, I'm not sure why the person would do that. So this is the fuse, and someone, I suppose that is the repair that they did. So they had to breach the fuse. So when you have, okay, so first thing first, let's just confirm we don't have or show, and then also if you want to, if you need to bridge your fuse, you cannot defeat the purpose of the fuse. So the fuse is there as a form of protection. So if you have to run a wire across your fuse, it has to be a tiny wire to substitute to substitute the existing function of the fuse. Otherwise, what's going to happen now? The fuse is supposed to cut out when it detects irregularities in the circuitry. So let's give you guys let's open up the schematic, give you guys an idea of what I'm trying to say. So this is an 80.00165. Let's see, 80.00165. So let's go to U7701. U7701 is going to be the backlight circuitry. Now, okay, let's open up the board view. 80.00165. Where are you? Here you go. Okay, so we are here to confirm why they had to breach the fuse. So this is the fuse here, F7700. Now, so what this is, let's go back to F7700. Okay, so this is F7700. This is the beginning of the circuitry. Now, so your U7701 requires PP bus, which is going to come through your F7700, and then it requires PP bus to process its boosting process, whereby you now get a higher voltage, which is going to be the final output of which is the end result of U7701, which eventually is how you get a backlight on your screen. Now, if you do not have voltage here, if you do not have voltage across your fuse, so if you have 8.6 volt here and then you do not get anything on pin 2, so it means that the voltage required for U7701 to preset its boosting process would not be available. Now, usually what will happen is if you have a problem in this section of the board, say like a short, for example. So what happens is the fuse is supposed to blow out, which is its ideal design to do so in order to prevent further damage. Because when it blows out, you have voltage here, and then voltage doesn't continue, which is ideal. That is what it's supposed to do. However, if you make a permanent connection here, it means even when you have a problem here, you have a constant supply of voltage onto the other side of the circuitry, and then whatever it is that the fuse has blown up for will just you just further damage whatever damage that initially blew up the fuse will just continue. I mean, because now you're pumping voltage onto the line. So a constant voltage onto the line. So if you need to run a wire, if for some reason you do not have a replacement fuse, and again, before you even have to run a wire, you need to first of all find out if you don't have continuity across your fuse. You first of all need to find out, do you have a short on this side of the board before you run wire to it. And if you and then if you find that you don't have a short on this side of the board, I mean you have pin 1 and then you have pin 2, and then the fuse is basically like a wire that bridges one section and onto another. Now, if you don't have a short, you need to use a tiny wire, a wire that will play the same role as what the fuse was in a situation whereby that is so that when there is a short, the wire can still easily break. But what we have here, this is a complete this is no, you cannot do this. I mean, this is basically more like you're putting a solder blob across pin 1 and pin 2. This should not be done, and this is wrong and it should not be done. So before, we're not sure why they had to do that, but I suppose we're just not sure. So first of all, let us see if we have a short across our let's see what we have. So what do we have? Is our continuity? Okay, so let's see, do we have a short on our back and output? Okay, at least we don't have a short. Okay, so first thing we want to do is we want to remove this. We need to remove that. It's wouldn't be ideal for us to leave that in place while working on the board. Yeah, so that is removed. So what if we don't have that in place, what we need to do is to actually use a tiny wire. But in this case, we are not going to do that. So let us see why. So let's see if that fuse itself was faulty. Okay, so the fuse itself was faulty. That was why they had to put a solder blob there. But that was not what needed to be done. I mean, that was the idea. You need to obviously ensure continuity again across the fuse. However, the way it's done, it's not how it should be done. You cannot put a permanent connection between pin 1 and pin 2, because that solder blob that is there is going to form a permanent connection across it will form a permanent connection across pin 1 and pin 2, where the fuse is supposed to play a role. So we now just let's get another board. We can use this one. It's just confirm that our fuse it's fine. It says an A1278. You can use a fuse from A1278. You can also use the backlight driver from A1278, and you are pretty much good to go if you do that. Okay, so that is in its place. What we want to do is we want to start to understand. Yes, we know that the fuse was blown. We want to know uh, what state the backlight section is, and then we take it up from there. Okay, so the fuse is now in place. Now we can connect the charger. We have confirmed that we don't have a short on the other side of the fuse, so it's safe for us to connect charger to the device. And it's also safe for us to install a fuse, because I mean we've confirmed we don't have a short. So we're not expecting to have backlight, because this is basically in the same state the device was. I mean, the fuse was blown, but then they had to put a solder across the fuse to obviously ensure continuity. So we're not expecting any changes. What we're just trying to do is we're trying to um, uh, retain, we're basically trying to place the device back in its original state that it came, but having to remove the solder blob that was used. So now let's see. So what you want to do now, we want to see what we have on our backlight output. So we can confirm that by checking here. So this is going to be our backlight. So by backlight output, I mean, so here we want to measure to see what we have here, which is after the boosting has apparently taken place. So we will be checking from here, C7796, C7797, C7799. So let us see what we measure at those caps. So C7797, C7799. Let us see what we measure at the backlight outputs there. So our black probe on ground, and then our red probe, let's see what we have. And we have 8.5. So 8.5 simply means that we are not boosting. So now with 8.5, so what that means is this. So it means that everything from this section here from pin 1, everything from this section up until the boosting phase, it's okay. So we are not going to worry about Q7706. We're not going to worry about F7700. We're not going to worry about if Q7706 obviously is opening. We're not going to worry about the EDP backlight enable signal. We're not going to worry about anything here, because if this was not working, we would not have 8.6 volt on our output. So because we have 8.6 volt, it means that everything here is working. We only need to worry about the boosting phase of it. So let's take the board out and find out why we do not have boosting. So let's quickly take the board out and find out why we are not boosting. So right now we have confirmed that we are not boosting, and that we confirmed by measuring 8.6, which is the PP bus voltage. PP bus voltage that came across from our F7700 is exactly what we are getting at our PP bus output, which means that the voltage is not being boosted. So let's take the board out and find out why that is the case. So in doing so, we are going to head over to our U7701, which is the backlight driver itself. And yeah, and then we take it off from there. Okay, the board is out. Let's put the shell on the side. Now the E7701 is going to be, let's flip to the other side. So this is going to be 7701. That's the backlight driver. By the way, you can this same backlight driver. It's what you can find, what you will find on A1278, A1286, which is the 2011s, the 2012s, the 13 inches, A1278, 2011, 2012s. They use the same backlight driver. So now let us. So this is the chip itself, the backlight driver, and let's see why. Okay, so it seems like we have a bit of a corrosion around it, a bit of corrosion around the chip. So let's remove it and install another one. And by the way, this is a 2017 MacBook Air. While installing your U7701, you have to be aware of its orientation. So I'm not sure if you guys can see that. So yeah, so these two pins here, they seem to be, so which is going to be pin 6 and the 6 and 7, and that is your LCD underscore boost. So those two pins seem to be off from the chip itself. So that is most likely our issue. So right now, what we are going to do is we are going to replace the backlight driver and then take it off from there. Okay. So this is liquid damage. Let's see if our backlight driver here is still fine. Mm, mm. Okay, let's check that out. Yeah, the backlight driver is fine. Nah, it's not. Nah, nah, it's not. We can use that. Let's grab another one. This has been taken off. Yes, we can use this. Okay, so let's see. Uh, yeah, we can use this. Let's just confirm the orientation. So, mm, pin 1 is going to be here. Okay, so pin 1 is going to be here. So which means mm, pin 1 is going to be here. So which means and then pin 5 will be this side. Okay, so if pin 5 is that side, pin 5 it's here. Okay, so pin 5 is there, so it means it needs to flip like this, because I mean pin 5 is this side, yeah, so pin 5 is this side and the pin 5 of the MacBook is this side, so we basically need to flip it like this. Wait, pin 5 is this side. If we flip it like this, yes, and pin 5 is here, so then we have pin 5 here. Yeah, that's it. Because but pin 5 of the MacBook Air is here. This is your pin 5, so pin 5, so yeah, so that's correct, that's correct. Okay, it looks good. The air is still not on recovery yet. Oh, okay, it's about to. Okay. Okay, so that is that's installed. So two things. Sometimes when you first time, so sometimes when you install it, it doesn't work. You have to change the installation method. But let's hope it works. So we are gonna grab a test screen. Connect our charger. Uh, okay. We have found Spain. Do we have backlight? Do we not have backlight? No, we don't have backlight. So we still do not have backlight. We have, however, we have display, but we don't have backlight. So let's change the installation method, which is we have to press down the chip a bit. Uh, uh, yeah, reinstall macOS. I believe the drive has already been wiped. So you just give it some time. It's gonna take time because it's internet. So what we want to do now is we want to press down a bit. Yeah, like that. Okay. Let's try again. Okay. Yeah, there you go. That is backlight. So I'm just going to clean up the board now, and then we can test with the client screen. Uh, okay. Okay, that's done. Next thing we want to do is test the client's display. So with this, we just need the screen connected as well as the DC jack. We are now going to connect the other cables. Okay, now let's connect our charger. We have a fan spin, we have a fan spin. Okay, let's just see, do we have an Apple logo? There you go. That's a beautiful Apple logo. Okay, so this is a completed repair. We are not going to wait for it to boot to desktop. We have other jobs to do. So pretty much, so this was an issue of U7701 being faulty, and that was specifically at pin 6 and 7 of U7701, and that took out the fuse, which obviously blew up the fuse. And the first repair attempt, when they checked, they saw that there was no continuity across the fuse, which is the approach was okay. I mean, the understanding they had that yes, there was a voltage on pin 1, but you have nothing on pin 2, which is a PV bus, and then and there was nothing on pin 2. That was right. However, the methodology or the method in which they use to carry out the repair was not ideal, because when you install a fuse like that, then you stand a chance of having to damage to obviously to damage the other section of the circuitry in case of any risk for the fuse to trip. So we replaced the fuse, and then we saw that there was no boosting taking place. We then had to trace our way to U7701, and then we removed it, and then we found that pins 6 and 7 were actually off, which indicated that there was an issue with U7701. We replaced it the first time. The solution was not properly done because there was no proper communication underneath the chip itself, owing to the parts under the chip. So what we had to do was to reinstall it, and this time we had to press the chip down, and that gave us proper connectivity, and now we have a fully functional backlight. So thank you guys. I will see you guys in the next one.